Okay, let's look at this physics question. Okay, let's look at it. I think this is also one of the subjects science students, some science students find a bit difficult because they are unable to relate the theoretical aspect of physics to the practical aspect. And I'm going to do justice to that looking at this question. So we have a man walks 1 kilometer due east and then 1 kilometer due north. One is displacement, and we have several options on the board. All right, quickly. Now, before I go into this question, you must understand first of all that um, there are two um, quantities in physics. All right, and that I'm giving students a lot of problems. The other quantities give them a lot of problems, but majorly these two, mostly when they are giving questions to solve, and they are what I call distance and then displacement. Distance and displacement. Now, one similarity between these two quantities is that they have the same SI unit, alright? You can either measure the meters or kilometers, as you can see in the respective options on the board. So distance and displacement. Now, how do we know that the question is talking about distance and how do we know that it's talking about displacement? It's clearly spelled out here that we have to move for the displacement, and that's because if you look at the options given, apart from the fact that values are given in the options, there are also directions also. And that is one of the things that distinguishes displacement from distance. We say displacement is a vector quantity and distance is a scalar quantity. A vector quantity because it has both magnitude. Magnitude simply means it has value. You can see 1 kilometers, root 2 kilometers, root 2 kilometers, 2 kilometers. So it has value. And apart from the fact that it has value, it also has direction. That is displacement. Displacement is the distance traveled in a specified direction. Distance is simply the total length of the motion of a body, the total length, the total length. So if I say, for instance, your body moves 3 kilometers east and 4 kilometers north, all right, what is its distance? So the total length, that is 4 plus 3, is 7 kilometers. That's distance, irrespective of the position, irrespective. So it does not recognize the fact that the body moves in a given direction. That's why it's a scalar quantity. But displacement, on the other hand, is a vector quantity because it takes into consideration the direction. And that's why another difference between displacement and distance is that distance, the value, the magnitude of the distance can either be positive or zero. But for displacement, the magnitude, which is the value, the numerical value, can either be positive or negative or zero, depending on the direction. So direction is key when talking about displacement. All right, enough of the super story. Let's now go into solving this question. So since we know that we are dealing with displacement, let's go on solving this question. Now, we said that a man walks 1 kilometer due east. So now for the man to walk due east, he must have a starting position. We call that in physics a reference point. So he has a starting position. So this, let's say this is the starting position. So from here, this is, let's say we have this. So he walks 1 kilometer due east. So we have, this is north, south, west, and east. So he walks 1 kilometer due east. Direction 1 kilometers. This is the starting point of the man. He walks due east. And then 1 kilometer due north. It was at this point. Then he walks another 1 kilometer in the northern direction, due north. Another 1 kilometers. 1 kilometer rather. Then his displacement. Now, how do we get his displacement? His displacement will be the distance, his current position. Yeah, displacement is the change in position of a body from its final position to its initial position. From its final position to its initial position. Now, the So how do we get the displacement of the man? So look at the distance from its final position. Okay, let's call it starting point A, and let's call this point we go to, let's call it point B. And then its final position, point C. So the total change in position from the total distance from its final position to its initial position, that should give us the displacement. So how do we solve this? Looking at this, we have a right angle triangle on the board, and we know that solving right angle triangle and looking for distances in a right angle triangle or distance in a right angle triangle, we use simply the Pythagoras theorem. Pythagoras theorem. Alright? So we will come over to this side. We want to use Pythagoras theorem to get the displacement. So this is our displacement. We want to find the change in position of the man from its final point to its initial point. Alright, so we use Pythagoras theorem. So let's call this point, let's call it point D. D for displacement. So in Pythagoras theorem, we have that the hypotenuse square gives us the opposite square and then the adjacent square. So the hypotenuse is our D, so we have D square equals to 1 square plus 1 square. Now what do we have? D square to give us 1 plus 1, which is equals to 2. So how do we get D? We'll take square root of both sides. So D square equals to 2. The square root of both sides, D, should give us square root of 2 kilometers. Now, for interesting, funny enough, we look at the options. We have 2 options. So we've successfully eliminated 3 options. We eliminated option A, eliminated option B, and also eliminated option E. So we are left with option C and option D. Now we're getting root 2 kilometers as our magnitude of the displacement. Don't forget what I said initially, that displacement is a vector quantity. It has both magnitude and direction. It has magnitude, it has numerical value. We have gotten the numerical value, the number. We have gotten it. Now, direction. That is what makes it unique. How do we get the direction? Will it be 45 degrees or 60 degrees? So we eliminated option A, eliminated option B, and eliminated option E. So how do we get the direction? Alright, from our diagram, we come back to this diagram. The direction traveled from our diagram, we look at to get the direction, we look at the angle the displacement forms with the horizontal axis. This is the horizontal axis, this is the displacement. The angle formed, let's call it angle theta. So the angle formed between the horizontal axis, the horizontal axis and the displacement. But if you want to name it, we'll come to that to get the direction. Let's get the direction first of all. Now, to get the direction, we have opposite. This is our opposite side, and this is our adjacent. And we know from SOHCAHTOA, let's come over to this side. From SOHCAHTOA, we have that if we have opposite and adjacent, that leaves us with tan theta. So we have tan theta, which is opposite over adjacent. Alright? And then opposite is 1, adjacent is 1. So therefore, tan theta is equal to 1. So how do we find theta? We take the tan inverse, or we divide both sides by tan. So that theta, which is something as 1 over tan times 1. 1 over tan times 1. Okay, let's finish up our solutions. On this side, 1 over tan times 1. So we have, from this place, we have that theta is equal to tan inverse. Because in indices, take note that if you have 1 over b, that is the same thing as b raised to power minus 1. If you have 1 over 2, that's the same thing as 2 raised to power minus 1. So if you have 1 over tan, that's the same thing as tan raised to the power of minus 1. So we apply the same thing, law of indices. Inverse law, or call it a reciprocal law. So we have theta is tan inverse 1, and if you use your calculator, you see that tan inverse 1 will give you 45 degrees. Now, in which direction will the man go? The man moved 2 kilometers. Now, to get the direction, to get the angle theta, I told us, we use the angle, the lines formed by the displacement and the horizontal axis. Now, in which direction will the man travel? Don't forget. Let's take this off now. Now, don't forget that this was how we had the original diagram. If you can remember, yes. So the man moved here, and he also moved here. Okay. So now we have 45 degrees here. So we have 1 here, we have 1, and we have root 2. Now, we can't use 45 degrees to give our direction. So what would we do? Because we have north and we have east. And if we use this 45 degree, we're going to be saying 45 degree east, 45 degree north, which is wrong. We can't say east, 45 degree north. We can't consider this angle. We can't use this angle. So the angle we can use is the one formed. This is northeast angle. Northeast angle, the angle here. So, and how do we get this angle here? This is a right angle, which is 90 degrees. So to get it, let's call this angle, let's call it alpha, for instance. So to get alpha, we say 90 degrees minus 45 degrees. And that gives us what? 45 degrees. Now, you may assume that this 45 is the same with this. Fine, it may be the same in value, but in direction, they are not the same. Because there are cases where you solve for theta here, and you get 30 degrees, and some students write not 30 degrees east. You missed that question. So what we do, once you've gotten the angle formed by the displacement and the horizontal axis, subtract that angle from 90 to get the direction. So the direction will now be north. We're starting from north now, look at it. North. So that will be north, 45 degrees east. Because this is northeast line. This line is northeast. So we can't say east north. You get the point now. So northeast, so our direction, our magnitude is, we got sub 2 or 2 kilometers. While our direction is what? Not 45 degree east. Or we can say 45 degree east of north, not 45 degree east, or 45 degree east of north. And that leaves us with option C as the correct answer. Thank you very much. We'll see you in the next class.